Hi, this is Mrs. Kalinicki. Just my little Bondi guy. We're here to talk about Unit 4, which is equations. I know it says 6 on your worksheet, but don't worry about that. It's Unit 4, equations. This is a review. So again, print out the study guide and do it along with me, or try some of the questions and come back and look and see if your answers are correct. Some vocabulary that you're going to need to know is the word equation, which is any expression that has an equal sign. An expression will have no equal sign, but an equation must have an equal sign. Solution is another word for answer. So if they are looking for a solution, they're looking for the answer. Some things you're going to need to know: how to solve 1- and 2-step equations, how to translate words into equations, and to solve equations with rational numbers. Rational numbers are anything such as decimals, fractions, even integers, which stuff we've already gone over. All right, let's get to it. Some rules and tips and tricks. The first thing I want you to do is look and see what operations are happening first, and then do the opposite. For example, here you notice 5 plus y equals 7. That's an adding problem. In order to solve this, I need to do the opposite of adding, which is subtracting. So I'm going to subtract what is next to my variable, so I can isolate the variable, because at the end I want it to say y equals my answer. Okay? So I'm going to subtract 5 on both sides to keep my equation balanced. That's a terrible 5, my apologies. 5 minus 5 crosses out. Make sure your answers do that. And then I get y equals 2. 7 minus 5 is 2. Cool. Another example. Here, I'm doing 4 times x equals 24. So because this is multiplying, in order to undo that multiplying, I have to do dividing. And again, I want to do dividing and isolate my variable x. So I want to get rid of the 4. So I'm going to divide both sides by 4. Showing the dividing by using a fraction bar rather than a division symbol. 4 divided by 4 becomes not 0, 1. And 1x. 1x is the same as x, so I can just write x, or I can write 1x. 24 divided by 4 is 6. So 1x equals 6, or just plain x equals 6. Cool. All right, some more examples. 72 equals 8 times c. It's okay if it's written this way. Don't get freaked out because the answer's on this side and the variable's on the other side. Again, I'm multiplying. So in order to undo this, I have to do some division. Divide by the coefficient over here, so that way when I do 8 divided by 8, I get 1 c. And 72 divided by 8, that's a math fact, that's 9. So c equals 9. All right, here's where the rational number situation comes in. I have the rational number 2/3 times x equals 6. I can do the same thing I was doing here, undoing my timesing by dividing. So I can divide both sides by 2/3. What might be easier, and I'll do it both ways for you. Here's 2/3 x equals 6. So I can divide by 2/3, but look at how messy this looks. Divide by 2/3, yuck. A calculator would make this pretty easy. I can do 6 divided by 2/3 in my calculator. 6 divided by 2/3. Oop. 6 divided by 2/3. And I can get 9. It's pretty easy on the calculator. So if those divide out to 1, and I would get x is 9. Now if I didn't have a calculator, it might be easier to use the multiplicative inverse. If I multiply by the reciprocal, look what happens. 2 times 3 is 6. 2 times 3 is 6. 6 over 6 is 1. Amazing. If I multiply by the reciprocal on the other side, these guys will cancel each other out. 6 over 1. 6 times 3 is 18. 18 over 2. That's the same thing as 9. Right? 18 divided by 2? That's 9. So 2 different ways of doing it. If you have a calculator, it'd probably be easier to do this division. If not, I would multiply by the reciprocal using the multiplicative inverse property. Yep, those properties do come in handy. All right, next one. Again, some notes. Instead of PEMDAS, which is what we do to evaluate an expression, you're going to use something called SAD-MEP, which is just PEMDAS backwards, to work backwards to solve your variable. So you're going to do any kind of adding or subtracting first, and then you're going to do your multiplying or dividing. So it's exactly like PEMDAS, but backwards. Okay, what is the solution to this equation? Negative 1/5 x plus 2/5 equals negative 13/15. Yuck. All these sorts of fractions. So again, pretend like it's an easier question and attack it first. So I see here there's some timesing, and I see here there's some adding in the way of me getting to that variable. So I need to do, again, SAD-MEP, adding or subtracting first. So I'm going to have to subtract 2/5 from both sides. Now, I cannot do this subtraction because I do not have equal denominators. So what I'm going to have to do is I'm going to have to make equal fractions by using a common denominator. This one just happens to be 15. So I got negative 13/15 will stay up here. And we'll change this 2/5 into something over 15, timesing by 3, timesing by 3. So a negative 13 and a negative 6, 13, 14, 15, 16, 17, 18, 19, negative 19/15. I'm going to leave it like that for right now because I'm not done with the problem. Equals, now again, 2/5 minus 2/5 is nothing. I'm going to copy down what I did not attack yet. Again, I'm going to use my property of multiplying by the reciprocal. Still has to be negative. Negative 5 and a positive 5 will cancel each other out, and a negative 1 and a positive 1 will cancel each other out. Negative times a negative is a positive, so these will all cancel. And I'm left with x equals, and I just did multiply this guy by negative 5/1. And I will get a really big number. I believe it's, let's see, let's do 19 times 5. Ooh, 95. Positive 95/15. And a negative times a negative is a positive. So now I just have to do 95/15 and see if I can change this second and hit fraction decimal. 6.33333 repeating. Looking at my choices here, the only one that is 6 anything is this guy. So 6 1/3. Okay, now on to some practice questions. Solve for x. Okay, so there's two different ways to do this problem. One way, if you notice something happening here, this is one of our properties too. It's the distributive property. I can distribute first. 3 times x is 3x. 3 times negative 4 is negative 12 equals 27. And now I can solve this problem. Again, using SAD-MEP. Here's timesing, here's subtracting. I have to undo the subtracting first by adding 12 on both sides. 3x, my 12's cross out, equals 39. To undo the timesing by 3, I have to divide by 3. And I get x equals 3 divided by 3 is 1. 9 divided by 3 is 3. My answer is 13. That's one way to do it. Okay, I'll show you another way. Erase all this. Another way is to just see this as a problem involving multiplying and subtracting. Now, if I knew what x was, I would plug it in here and I would do the subtraction first and then the multiplying. Since I'm going backwards, I would do the division and then the adding next. That's another way to do it. You can divide by 3 on both sides, where my 3's will cross out. And again, the problem is really easy at this point. Add 4 to both sides, and you'll still get 13. Okay? A third way to do it, again, using multiple choice strategies. If I have multiple choices to work with, what I can do is start with the first answer and see if it works. I'm going to plug in, instead of x, I'm going to plug in 13 and see what I get. If I get 27, then I know it's the right answer. 13 minus 4, well, that's 9. 9 times 3. Hey, doesn't that equal 27? Yeah, it does. 27 is 27. So that's another way to do it. 3 different ways of solving the same question. Isn't that great? That's what math's all about. All right, next question. Vinny wants to join a new gym. There's an initiation fee, that's usually like a starting fee, of $29.99, and each month of membership costs $14.50. If Vinny pays $160.49, write and solve an equation to determine how long his membership will last. All right, sounds good. So let's start this off. Initiation fee of $29.99. Again, I'm reading the question and kind of writing some information as I go. And each month, each means timesing. Each month, he has to pay $14.50. Now, they don't give me a letter or a variable, so I'm going to pick the letter X. The letter X is going to represent how long his membership will last. And we know the only amount of time, how long, they told me is months. So X is going to represent the number of months. Yes, that's not a hashtag, that means numbers. Okay, so again, because each month costs $14.50, I'm going to put my X right next to the $14.50. If he pays a total of $160.49, that's my equation. Now let's look it over one more time. I pay this much money right at the beginning, and I pay this much each month, depending on how many months there are, and I got $160.49. All right, sounds like it makes sense. So now I'm going to solve it. I just wrote the equation, and now I have to solve it. So I am dealing with some adding, and I am dealing with some multiplying. What do I have to do first? According to SAD-MEP, I have to do my adding or subtracting first. So I have to get rid of this adding by subtracting. What am I subtracting? Well, this $14.50 is multiplying by X, so I have to get rid of the $29.99 by subtracting. Again, make sure your subtraction sign is there. Sorry for my terrible handwriting on the smartboard. Cross this guy out. I'm left with $14.50. X equals, do some fancy calculator work, 130.5. All right. And now, let's extend my page a little so you guys can see my work. And now I can do my division to get rid of this multiplying, dividing both sides by $14.50. Again, using our calculator to do this division. And I get, do I get exactly 9? 130.5 divided by 14.50. I get exactly 9. So in order to pay $160.49, I had to have gone to the gym for 9 months. Cool. Next question. This is a nice simple translation question. What is the number? 5 more than twice a number is equal to 19. Okay. Read it one more time. 5, that's 5, more than's a clue word for adding. Twice a number. Twice means 2 times. 2 times a number. They don't tell me what the number is, so I can call it anything. Let's call it n or x, whatever you'd like. Is equal to, that's equal sign, 19. There we go. What is the number? Okay, here's my chance to solve it. I can guess and check, but solving it's going to be a lot faster. Again, using SAD-MEP, working backwards from PEMDAS, I would have to do my adding or subtracting first. I am adding the 5 on, so I have to subtract that 5 away. I get 2n equals 14. All right, because 19 minus 5 is 14. These 5s are going to cross out to 2n. And then, to solve, I have to divide both sides by 2. My 2's cross out, n equals 7. All right, the number is 7. Next question. I see a couple different things going on here. It looks like a 2-step equation, except I have some extra x's in here. Well, I don't like that. So what I'm gonna do is use a rule that we used last time in expressions, which is combining like terms. These guys are like terms, so I'm going to combine 4x plus 2x. 4 plus 2 is 6x. Just combine those two. All right, let's keep going with the rest of the problem. Minus 3 equals negative 51. Okay, didn't do anything except combine those two like terms to get 6x. Now, it's a two-step problem. There are two numbers in my way of getting x by itself. There's multiplying by 6 and subtracting 3. To undo that, we're going to use SADMET, working backwards, doing adding or subtracting first. This is subtraction, so I'm going to have to do the opposite, which is add. 3 on both sides. 3's will cross out,